Hey everybody, Mr. Mac here. In today's video, we're going to take a look at complex numbers. And we're going to learn how to add and subtract them, multiply and divide them, and simplify powers of I. So we know that when we have a negative underneath the radical, it's going to be imaginary. There's no way to take the square root of a negative number. So we are going to define the square root of -1 as I. Now, if we take I and square it, we're saying the square root of -1 squared, which the square root and the square cancel, so I squared would be equal to -1. We're going to use that a lot later. And this is going to introduce a new type of number for us, a complex number that has a real part that we write A and an imaginary part that is BI. And so I, again, that is our definition of square root of -1. Okay, so I've got 3 steps here for simplifying. We're going to write square root of -a as square root of a times square root of -1. We'll substitute I in for square root of -1, and then we'll simplify. So let's take the square root of -9 here, and let's separate it into square root of 9 times square root of -1. That's the product rule for radicals. The square root of 9 is 3, and when we substitute I in, we get 3i. Let's take a look at how we could look at this visually, okay? So plotting a complex number on the complex plane. Let's take this number, this complex number, in standard form, -2 plus 3i. So we're going to say that the x-axis is the real number axis, and the y is the imaginary axis. So we could take -2 plus 3i and plot it as a point -2, 3, where the -2 is the real number and the 3i is the imaginary. All right, hope that makes sense. Let's try a quick example here. Let's plot 3 minus 4i. Again, the x represents the real. The y would represent the imaginary number. And so 3 negative 4i, that's going to put us in the 4th quadrant. Okay, and that's all we're going to do for that. Maybe come back to that later. Let's see what happens when we add and subtract complex numbers. What we're going to see in this part is that I just acts like a like term. Okay, so we're going to combine the real parts and then we're going to combine the imaginary parts. As we see here in these two equations, we are grouping our real and our imaginary together, and then we'll simplify. So for example 3, I've got 3 minus 4i plus 2 plus 5i. We're just going to add the like terms together. So I'm going to put 3 plus 2 together, and then I got minus 4i plus 5i. 3 plus 2 is 5. Negative 4i plus 5i is I. Okay, and then we're done. This is standard form of a complex number. We can do the same with b. The only thing we have to be careful about is that negative in front of the quantity. So we have to make sure here that we're distributing this negative. So that's just going to change the signs inside of that set of parentheses in that quantity. So let's group it together. -5 plus 11 plus 7i minus 2i. And we get 6 plus 5 5i. Okay. Let's take a look at our next example. This time we're going to multiply complex numbers. And really, this is what we did all that work on multiplying polynomials. We just have imaginary numbers here and their rules that we're going to use. So let's multiply 3 into the quantity of 6 plus 2i. We just distribute and simplify. Okay, same with example 4 here. 4 times the quantity 2 plus 5i. We're going to distribute the 4. So we're going to get 8 plus 20i. And fix that 8 there. And that's our answer simplified in standard form. Now what happens if we're multiplying binomials together? We are going to use FOIL again. First, inner, outer, last. And whenever we get an I squared term, we are going to then substitute our value of -1. If the square root of -1 is I, then I squared would be -1. So in example 5 here, I'm going to take these two binomials, I'm going to FOIL them, and I'm going to group my like terms together, and anywhere where I see I squared, we're going to substitute in -1. And that's going to happen on this last term. 3i times -5i is -15i squared. It's highlighted there for you. 8 minus 20i plus 6i. Now here we get -15 times -1. Okay, so that's going to give us 8 plus 15, because -15 times -1 is a positive, minus 20i plus 6i. I've got everything grouped together now. I'm just going to add everything together. 8 plus 15 is 23. -20i plus 6i is -14i. And that's our answer. Okay, what happens if we are dividing a complex number? So we do not like having imaginary numbers in the denominator. And so we are going to use the conjugate pair that we've seen when factoring the difference of two perfect squares to get rid of the imaginary number in as the middle term. Now remember, when we had x squared minus y squared, it equaled x plus y times x minus y. Remember, if we were to FOIL x plus y times x minus y, the middle term would cancel. And so let's write this out, 2 plus 5i, and let's write it as a fraction dividing by 4i. Again, I don't want that imaginary number in the denominator. And so this is very similar to what we did when we were rationalizing denominators. We don't like radicals in the denominator. We don't like imaginary numbers in there either. So we're going to multiply this by its conjugate pair, which is 4 plus I, and whatever we do in the bottom here, we have to do in the top. Otherwise, it's not a legal mathematical operation. So now we've got to FOIL the numerator. So 2 times 4 is 8. 2 times I is 2i. Okay. 5i times 4 is 20i. And then 5i times I is 5i squared. That I squared is going to be substituted here in a little bit. And then look right here. We're multiplying our conjugate pair. The middle terms are going to cancel out. Now I'm writing it out now, but eventually we don't have to do that because we understand the pattern here of a conjugate pair. And let's take care of that I squared right there. And we have the I squared in the numerator as well. So let's simplify, substitute and simplify. Okay, I now have -5 there because I squared is -1. And also in the denominator. Okay, so what we got now? (8) minus 5 plus 2 plus 20i. And we got on the bottom 17, don't we? 16 minus -1. Okay, so 3 plus 22i over 17. Now I'm going to box this in, and this is fine, but we really would rather have it in standard form. So I'm just going to divide the 17 into the numerator, because our form of standard form is a plus bi. So that's going to be 3 over 17, and then plus 22 over 17i. This is the better way to write it. If you write it the other way, it's not a wrong answer, it's just not the way that we typically want to show it if it asks for standard form. Okay, very good. We're almost done here. We're going to simplify some powers of I here, and there's a pattern. So I to the first is just I. I to the second we know is -1. I to the third we can write as I squared times I, which would be the same as -1 times I, because I substituted there for I squared. And so we get -I. I to the fourth, we can rewrite that as I squared squared. Well, I squared is -1, and when we raise a -1 by the second power, by power of 2, it gives us a +1. Okay, so we got, for the first one here, I got I to the second was -1, I to the third was -I, and then I to the fourth is 1. Let's continue. I to the fifth is going to be I to the fourth times I. Well, I already know I to the fourth is 1, so this is going to just be I. I to the sixth, we can rewrite that. There's a lot of ways to do this, but let's say that's I to the fourth times I squared. I to the fourth is 1, and I to the second is -1. So that's going to be -1 times -1 is -1. I to the seventh we can rewrite as I to the fourth times I squared times I. We already know I to the fourth is 1. I to the second is -1 times I. That gives us -I. Running out of room here. I to the eighth we can say is I to the fourth squared. I to the fourth is 1, and 1 squared is 1. Okay, so let's write 5 through 8 out. And let's see if you notice something. I, -1, -I, 1. Well, we have just repeated the pattern. So let's say I to the ninth, if it repeats, it would have to be I. So let's check it. I to the ninth we can write as I to the fourth squared times I, and I to the fourth squared we already know is 1 times I is I. All right, I hope that makes sense. Let's do example 8. what if we have I to the 35th? What would this simplify to? So we already know I to the second is -1. So how can we rewrite I to the 35th in terms of I to the second? So we can say it's I to the second raised to the 17 times, we need one more I. So 2 times 17 is 34, times I would get us to 35. Let's substitute I squared in there, it's -1. If we raise a -1 to an odd power, it's going to be negative. So -1 times I is -I. And we're done. Okay, y'all, I hope that makes sense. It's a lot here. We'll do some practice and see if we can wrap our head around this complex situation.